Okay, hello back. So we will start a new series of classes. It's gonna be free classes, and after you will have the midterm, your test, where you will apply the knowledge you learn in the forces and in this series of classes about simulation. So today we will just speculate about what is simulation, why we focus on simulation, and why it's important for us. So we can start from simplest way. What is simulation? We can go to Wikipedia or we can go to Merriam-Webster dictionary. So simulation is an approximate imitation of the operation of a process or system that represents this operation over time. Okay, it's a little bit too science, I think, too technical, too academic. Simulation, basically, main word here is imitation, yeah. So where we can talk about simulation. So simulation using in many contexts, such as simulation of technology for performance tuning or optimizing. So what does this mean? So we use like physics simulation or simulation of some technology before we build in the real world to see how it's gonna be performed and how we can make it perform better. So for example, we can see the airflow simulation. Yeah, I think all of you saw this kind of images already. So when they design new car, new airplane, engine, engineers often doing this kind of simulation to see how the flow of the air gonna be inside, what the resistance gonna be, what the power it need, how much we gonna lose of the energy that receive it, or and so on. So like for turbines, yeah, for cars again we see how they can make speed up. So for example, with the turbine you have input and you have big one, yeah, small one. We start from small and you go with big one and then go output. So small diameter going to the big diameter, so it's increase the diameter area of the flow, so it's reduce the power of the flow going out. So in this case, if we use turbine, we can use much more strong flow of power of airflow to rotate this turbine. That will give you additional power for your car. Yeah, when you design air fan, you see, yeah, like for example Xiaomi, they have this fan that they create does not make any sound. Or when you see industrial fan, that is like very noisy. Why? Because it's how they design the these wings here, right? So all this can be done in the simulation, airplane simulation, how to reduce resistance to air, how to make it stable in the air, how to make it float, and you can simulate, you know, you can do earthquake simulation. It's kind of interesting also to see how the like some construction will resist for earthquake, right? So Basically, now in any field of science and technology, engineering, we use simulation. Why we start to use it? Because now we have computers. So from the beginning, even when computer was very slow, we start to, it was used mainly, I think it mainly was used for to making simulation and making approximation, yeah, for future. The same where we have the like moon program. When we send the first man to the moon, we use like very huge and very not powerful slow computer to calculate the trajectory and speed and time, yeah, when we need to send the rocket, what angle and how the like engine should works. So first, of course, this computer this time computer not really was able to calculate everything in real time, to adjust the position of the satellite of the rocket, yeah, they sent to the moon. So most of the thing was done in the simulation before even they sent this Apollo mission to the moon. So on the Earth they did like multiple simulation to run it, to see what's the right time, what's the right altitude, and so, and after they give instruction to the astronaut. And yeah, here was a lot of burden on astronaut. If something they see like going out of the what was predicted by machine, they need to adjust it, right? So we use simulation technology for performance tuning, for optimization, for safety engineering, testing. Yeah, okay, another way it's like training. Yeah, simulation it's very good, okay, to do training. The same here, the image, it's training of astronaut. But how we can rebuild this like zero gravity environment on the Earth? We can use pool, yeah. In the water, pretty much you have zero gravity. I mean, you have resistance of water, the drag force we learned in previous classes, that going against the gravity, because water have enough volume, not volume, how it's called, I forget the word. Anyway, education. So simulation, it's very useful for, again, education. Yeah, when you learn something, you try. Again, training education, I think it's pretty much the same cases, like training, like flight simulators, or whatever simulators, like car simulators, I don't know, extreme situation simulators, and so on, so on, so on, yeah. Even was funny things, last year in the States, they did simulation of this like pandemic of the virus. And the funny things that, yeah, the simulation shows that, okay, US does not ready for this really, but yeah, anyway, simulation show, they give report, and they still didn't ready this year. So why they did it? Good question. And now I think what it could be more interesting for you as artists, this is pretty much simulation, it's video games, yeah, and we have like virtual reality now, where you can simulate the real world. Basically any project that you're doing, it's about simulation. You remember last semester, one of the first class, what I told and what your task was to see for patterns, see how things work. I tell you, if you understand how things work, you can make it happen, you can program it. If you understand how to draw this image, you can explain it to machine can do it. If you understand how humans behave, how they interact with some tools, you can program this interaction and you make your interactive work, because you can predict the behavior of human or you can lead them to the behavior or actions you want to happen when you're doing your interactive installation. Okay, even if I will go to Pinterest now, for example, we can just go some okay, you see most of things that people doing in their life, they're doing simulation of something. Theater, simulation of the real world on the stage. Now we can use mapping, it adds some environments. Yeah, you have like some more physical things, something more interesting. So basically theater is a stage on stage simulation of the something happened in the actual or imaginary world. Yeah, often it's imaginary world happened. Okay, yeah, so we have theater on stage simulation, we have the painting, the images, that again is a visual representation of some simulation of the objects that happen in our brain at the end, right? How you imagine it or how you see it. It can be from real world objects, or it's something like from imaginary world that happened in your brain. We have a lot of these current time popular media space, how they call it. Yeah, basically you get the space, you add some lighting, some projection, some interaction. It's good for brands, for commercials use. It's kind of like more commercial version of like TeamLab. There's like interactive environments, right? But again, all what's here is simulation of something. Okay, it's not real world. Okay, this is not like what really happened in real world, but it's to make the experience of people a little bit more interesting and to have this like wow effect. Okay, if you're gonna get fit, you go to the gym, yeah, but now all we wanna, it's entertain, it's fun. Yeah, you go to gym now not to get fit, but to get some fun. It could be good, it could be bad. We're not gonna talk about this much. Yeah, but this is very common use now again. And again, to program this kind of environment, you need to understand how people interact with it first. You need to simulate, at least in your brain and virtual space, how people gonna interact with it before you finally design it and build it. This kind of stuff. So what's the simulation of what here? I would say it's simulation of some equation, physics, or like it's mathematics. I would say it's mathematics here, math. Yeah, so we build a portrait with just like different algorithms that you can simulate. It's more like Voronoi or like triangulations, different like cellular recognition physics. So you can find a lot of simple algorithms that explain. Again, one of the famous now and very popular everywhere, again, this of reaction diffusion, yeah, animation. It is one of the simplest physics, how two liquids or two materials, it could be not really liquid, but with liquids it works better, interact with each other. yeah, how they mix, how they evolve. Like last year we talked about you remember we have Cellular Automata. We designed simple game of life that is again it's simulation of the simplest organism pretty much in the world, and again it's simulation of something that exists in real world, but it can be much more far away. You see, it can go to more like artistic representation because you can use the Cellular Automata not just to even generate this kind of like nice looking patterns. You can go to 3D, you can design like really environments. Maybe why you do not use the Cellular Automata, try to design the architecture, try to design some spaces, some environment, some products, yeah. And yeah, the one said things, the after, the one who invented, the father of Cellular Automata, it's died around 2 weeks ago from virus. Matney, he was quite old already. Anyway, so this is one of the way, and we have this is a huge topic now. Artificial intelligence. What is it? It's our attempt to simulate our human intelligence, our human brain, our human mind. So all the technology airbase behind artificial intelligence was built on our understanding on human brain and neuroscience, right? That's why we did not move so far for now, because it's still very big question for us what our mind is, what consciousness is, what it means to be a human again, yeah, to be in what is intelligence. We even cannot answer on this question now clearly, but that's where we pointing on, where we want to move. Like humanity, we want to understand our brain more with machines or through machines. What happened now, yeah. So basically most of algorithms or research is based on simulation of some aspects of human brain. Okay, this is not much interesting here. Okay, most of interactive installation, it's somehow the simulation of some simple physics, right? When you touch something happen, okay, this is like pretty much very simple simulation of physics. You have some particles, they move, they collide, they interact, pretty straightforward. This kind of simulation is like DLSL, kind of like glitchy environments, strips, yeah, like fluids. Basically, it's like fluid simulation. All of the things we're doing is simulation at some point, or the most of the computer graphic, most of digital visual art, it's about simulation or representation. Okay, here not much. I think it's more for like real-time visual art, I can call it. So most of the things at some point is just simulation of something. So we have games, right? We have environments. We have our real world and virtual world. We have the technology and engineering where we're doing our simulation to test or to design the product. So from what we start, okay, the simulation, basically the grow on computer science and technology give us the ability to do this kind of simulation, and then much more power we have now, computational power, yeah, then much more compute we can do, then much more faster our machine, then more complex environment we can simulate now. Again, if we have like the real world, physical world, right, we have like a lot of simple equation that pretty much can explain most of things in this world. Not all of them we know yet, but you can see if you have like two objects, two molecules, how they interact with each other, you can simulate it. The more compute power you have, then more and more molecules or like environment you can simulate, so you can simulate more complex system, right? So we can start from the atom simulation, it's the one, and we can go to the like universe simulation. It's actually exists kind of interesting this like universe sandbox you can try. It is very interesting. It's basically simulation of our universe. You can install on your computer and play with it. So it's nice looking graphic first, but the second also you can you can fly from the space. And see how simulate how the things was and how they now and how they can be in the future. Or you can move, for example, the position of the Earth a little bit and see how the climate, how the temperature gonna change if we like Earth will change the orbit around Sun. Or you can put another sun close by to see how the two sun gonna interact with each other and how it will affect our universe, our environment. I mean, it's kind of interesting and fun to play, nice graphics, and so it looks like universe. It's kind of simple, yeah, but we have a lot of equations for this at the end. We have some basic fundamental one, but yeah, when you can simulate and see and predict what's gonna happen, how it's gonna happen. It's very interesting. First, and second, yeah, it's very good for researchers to see, to predict the future. I highly suggest to check this Universe Sandbox too. It's very nice. So when we talk about simulation, I would suggest you one more interesting topic. So when you start to think about simulation, one of the first question is like, does we living in the simulation? Can the world around us be a simulation? And here it's like multiple theory and ideas around. Also the way how you think about simulation. By my opinion, each of us living in some kind of simulation because each of us have different experience. Different. By the experience, I mean the place where you grow, the environment you live in, the books you read. So each of the event, all of this experience change your life and change your brain. So in the way it's changed the way you perceive the world. Even we will be close in the same room with different people. Each of us will see this room different way, based from what kind of experience you have in your life. For example, the people from north, like north of Russia, or like north countries where a lot of snow, they have much more different gradation of the white color. For example, they can distinguish it. The people from south, they do not have so much gradation to white colors. For them, the white room gonna be just white. So for some people from the north, it can be different colors of white. When you see some text, your understanding of this text is gonna be based on what's your experience, what you learned before, what you read before, what you saw before, what you experienced before. Different from what the other experience was. So this is kind of like my opinion. We're living in the world of like 7 billions of different simulations that happened at the same time, simultaneously, not easy word. And that, yeah, of course, that somehow interact with each other, affect each other, but we still totally living in different worlds, each of us. That's why we have so much problem also now in our world with understanding. Yeah, this looks nice. This is one of the this is one of the nice things. You remember from the beginning I tell you about looking for references, looking for patterns in geometry. So when I have this kind of stuff, I can think how I can make it happen. I can think how I can simulate it. I can find equation. I can find formula to make my work. Especially if like it's something math based, it become much more simpler. Yeah, so you just like need to find right equation, right books. It was one of the interesting book. I do not remember that it's like really explaining a lot of math behind. For example, things like this, yeah, it's pretty much multidimensional spaces unwrapped to 2 dimension. And that's how it's gonna looks. So you see all of this stuff here is based on math, and you can build it, you can generate it with your program if it have some explanation, if it have some equation behind. So back to the theory. Yeah, each of us living in simulation. And the second theory I will suggest you to read. It's like Nick Bostrom. Okay, yeah, simulation theory. It's kind of interesting also. Simulation argument. If you're really interested in something more like fundamental, like philosophy, it's not so big. This one, it's like 14 pages with big letters. Yeah, I mean, it's like half hour read, 1 more hour to think, but it's kind of interesting understanding. So if to be shortly, I will tell, okay, he have like theory, so we have three possibility if we're talking about simulation. The one possibility is we will never reach the level that we will be able to simulate the real world, because okay, to simulate the real world pretty much we need a lot of computation, we need like very high technology, and in most cases it's also like great verbal theory if you're interesting. Yeah, great verbal theory, not of China theory. It's more about that like most of civilization will die before they will reach some high level of technology. They will destroy themselves. So this is first point of his theory, his argument. Most civilization will destroy themselves before they will reach the ability to produce that high level of simulation. Second one is with time we will lose interest to the simulations at all. We will think about, okay, it's not relevant, it's not interesting, so we're not gonna do it. And third one, yeah, we finally make the simulation, and if the third one win, in this case the number of simulation existing in the world, it's gonna be going to infinite number. Right, so if you can build one simulation, why you cannot build many simulation? Why inside of this simulation you cannot build other simulation? And at the end you have just one non-simulated world opposite to the billion of like infinite number of simulation. So in this case, most probably we're living in the simulation now, because the probability that now we're living in one of the like billion of simulations rather than in the one of the like original world, it's much more higher. So this is interesting topic if you're interesting to read, if you're interesting to explore a little bit more there. But even if talk about this kind of thoughts, I recently read book by another philosopher, Dennett. Yeah, it's kind of like his famous book, quite big, long read, interesting, very controversial. This book from 1991, so it's like pretty much 30 years ago. And one of the big points when he starts this book about the ability to simulate our brain, to simulate the environment, he pretty much thought it's pretty much impossible. We does not have this ability to do calculation. We cannot simulate the nice looking world. Of course, like 30 years ago, not much 3D, not much stuff, but yeah, I'm curious what he's thinking now about this particular point when we have virtual reality, when we have like Unreal Engine, that it looks pretty much real. But yeah, this is like long read again. So this is pretty much for first theoretical part for today. What I want you to do more today, like rest of the class, it's a little bit of your homework. I wanna make you think about this simulation. So what is simulation for you? What's your opinion about the simulation theory? For this one, I would like if each of you will write down short text. Okay, it's not 1, 2, 3 words, but I mean like one paragraph. I don't know, let's say around okay, here I have already 11 words, so let's say around 200 words. This is gonna be pretty much your review of today's class. And next 2 classes we're gonna do 2 simple simulation. So one is gonna be physics basic simulation, or I would call it real world basic simulation. Let's do simulation of this virus. How it spread. Basically we will build simple processing sketch where like each point will represent the one person, and this person could be sick, could be die, could be trade, and we can just see what we want the minimum distance between people, how it will interact. So yeah, let's do this one next class. I think it's hot topic now. It's touch everyone in this world. At the same time, it will give you ability to understand why we're doing simulation. Yeah, why we need this physics simulation, why we need this like real world simulation. And it's another point, it will give you a little bit more understanding also how this measure that making by the governments in different countries now affect the situation. And one more, I think it's gonna be let's see how long this will took, 1 or 2 classes. It's basic how much in details we will go. And after we can talk about simulation of virtual world. So it will be class, one more, or it will be test, your test. Because so this is first part of your homework. Write a little bit, review your thoughts, your understanding. And the second part of homework, to think about something what you want to simulate. Because after 2 classes, we will have the test, your midterm, where you need to show your understanding of the how to build simulation and your understanding about forces. So I want to prepare you to prepare for this text. Just again, it's second part of your homework. You need to write down what you want to simulate. Again, do not choose very complex. topic, choose what you can to build, but I think you can choose also something what interesting for you, in case how it visually could looks, or how it's like you just interesting how by tweaking some of parameters you can adjust the environment and see how it's evolved. It's more like for, so it's visual or research based, so you can do simulation to do some nice looking visuals, or you can do simulation like we're gonna do with the COVID. It's more research based to understand how the different measurement actions will affect the spreading of the virus. Okay, thank you. See you next class.